All right, so this is geometry, and this is kind of a code on each of the lessons, right? This is geometry, semester 2. This is the first unit, which is called trigonometry. This is the 5th lesson in it, which is called tangent, op, leg, and inverse practice. This is on Creator Math. It's under the Geometry tab. You scroll down a little bit, and you'll see it for semester 2. And the instructions they give us are copy the following problems, 1 through 15, into your composition book on the correct pages, according to the table of contents with the notes for those pages from creatormath.com. Don't forget the notes, you guys. Those go on the right pages in the comp book. And if you have questions about that, I'll answer it here in a minute. Okay? So some of these problems are going to start to look repetitive because part of the goal is to have you see the same problem, a little bit of repetition, they call it. They used to say repetition is the mother of skill, and that still works a little bit, and sometimes we'll miss it on the first run, so it'll repeat here, right? This says, given the figure below, what is the opposite leg or op leg for the given reference angle? So here's some background. This is a right triangle. How do I know it's a right triangle? Because of the square in this angle here called a vertex, or in the corner down here, right, is a square. It tells me that this angle is exactly 90 degrees. That is the definition of a right triangle. A right triangle has exactly one 90-degree angle. The reason this angle number 2 and angle number 3 cannot be 90 degrees is the total of all the angles, these three here, have to sum to 180. If I take 180 and subtract this 90, I'm down to 90. So the 90 has to split between these two. So neither of these can be 90. There can only be one 90 degree, and it's called a right triangle or a 90-degree triangle. So then the next thing you got to remember about triangles is triangles have three sides. This one's labeled side A, B, and C, but the three sides have names. There are legs, and a triangle has two legs like a human. I try to say like a human so you can remember that a triangle has two legs. The legs are always attached to the largest angle. In this case, it's the 90-degree angle, and attached means they're adjacent or next to this angle. The third side over here is the longest side, and it's across from the largest angle. It's called the hypotenuse, right? Spelled hypo, H-Y-P-O, 10, T-E-N, and use, U-S-E. But we don't say hypotenuse, we pronounce it hypotenuse, all right? So this is asking where's the op leg. Now, and they say the reference angle. So in trig, they're always going to tell us some reference angle. This reference angle is using an alpha. Alpha is a Greek letter. We often use Greek letters to describe a variable for angles. So alpha, beta, gamma will be new words possibly for you just to think about, oh, in geometry, and alpha is a variable for this angle. So this is the reference angle. This angle's 90, I already know it. This angle's blank, I don't care about it. I'm going to ignore it. I'm going to focus on the reference angle. Then they want to know what's the op leg. Well, there's a leg and a leg, right? One leg is right here, adjacent, touching the reference angle. The other is op, or across from. In geometry, opposite means across from. The op leg is side A to this reference angle. And just to give you some foreshadowing, if the reference angle is moved over here to this unknown angle, then the op leg would change over to side B. But for this, the op leg is side A. The next one is going to ask me what is the adj leg. So here's the reference angle again. And they say, given the figure below, what is the adjacent or adj leg to the reference angle? Reference angle is still in the same place, alpha, this one here. Adj leg, it's an adjacent leg. There's two legs, right, like a human. This is the leg touching the alpha. So adjacent means next to in geometry. So the leg next to this reference angle is side B. That is the adj leg in this case. Notice if this reference angle moves over to here, which it is in a later problem, then the adj leg would be side A. So the adj leg and the op leg depend on the placement of the reference angle, which is the angle we're talking about. Now they're going to focus us on the third side, given the figure below, what is the hype or hypotenuse, right? And I like to coach students and myself, if you're going to spell this word hypotenuse, which sounds strange to us because it comes from a long time ago, 2,000 years ago, right? Back in the day of Pythagoras, right? And Pythagorean theorem, we also have the hypotenuse. It's spelled hypo, then it's got the word 10, T-E-N, and the word use in there. And that's nothing more than just a way to help me spell it. I can spell hypotenuse, and I can actually spell this word, but you're going to pronounce it hypotenuse. Hypotenuse has two characteristics. It's the longest side. Notice side C is visibly the longest side. I can just look at this thing, this triangle, right triangle, and go, hey, that side C is the longest side, so I know it's the hypotenuse. It's also across or opposite the longest or the largest angle, which in a 90-degree triangle is the 90-degree angle. So anytime you have a right triangle, if you find the 90, go across from it, that's the hypotenuse. All right, so we're going to mark side C for the hypotenuse. Given the figure below, what is the reference angle? Now they want to focus us on this idea that we're looking at different angles. A triangle has 3 angles. In a right triangle, we already know 1. There's only 2 available angles left to talk about in a right triangle, and we want to know their measure eventually. And we give it an angle here, a variable. In this case, it's alpha. So they want us to just say alpha is the reference angle. And what that also should denote to a student is, hey, this one's blank over here. I am not focused on this angle. I don't care about it. I'm literally going to ignore that angle and focus on the one with the alpha in it. That becomes the reference angle. That's their way of saying focus on this angle, right? Now, what they've done for us is shift. Let's go back and see both of these together. They've shifted the alpha, or reference angle, from this angle of the triangle over to here, to the other unknown. And what they want to illustrate to us is when the reference angle changes, so do the locations of the op leg and the adj leg. So in the prior problem, when alpha was here, side A was the op leg. Now when we move the reference angle over to this one, we now are looking for opposite, or the leg across from this alpha down here. So now the op leg becomes side B, and I'm going to show you why this is important in a second. Sine, cosine, and tangent involve the locations of these 3 sides, the 2 legs, which a triangle has 2 legs like a human, attached to the largest angle, and the longest side called the hypotenuse. Those are the 3 side names. So here we are, the op leg from the reference angle is side B. They're now going to ask us the adj leg next to the reference angle. Given the figure below, what is the adj or adjacent leg? Adjacent means next to in geometry for the given reference angle. The reference angle is here. So the adjacent leg, there's 2 legs. Here they are. This one is adjacent to the reference angle because it is next to. Right? So side A is next to the reference angle and it's a leg. It can't be side C, even though side C is adjacent. It's next to this angle, but it's not a leg. There's only 2 legs. They're here and they're here. This side's called the hypotenuse. So that one's out. That cannot be the adj leg to this reference angle. It has to be side A. All right, given the figure below, where's the hypotenuse? Again, the definition of the hypotenuse does not change. Even though the reference angle has moved, that does not matter when it comes to the hypotenuse. So a lot of complications here. You see the legs moving around depending on where the reference angle is in terms of which is adj and which is op. But the hypotenuse is remaining steadfast, right? Side C is the longest side, and it's across from the largest angle. That's the definition of the hypotenuse. So side C is the height. All right, given the figure below, what is the reference angle? Again, they're just trying to focus on the idea that this shape, this symbol, means alpha. It is a symbol for the Greek letter A, alpha. All right, that's all they're trying to do is focus us on the reference angle. All right, trigonometry or sine, cosine, and tangent only work with 90-degree triangles. This is both true and not true a little bit. We're going to do the law of sine and cosine at the last 2 lessons of this unit. Those are used on non-90-degree triangles. So what they're trying to do is focus us on the practical side of trigonometry is sine, cosine, tangent. That is to be used with right triangles or 90-degree triangles. There's a memory device for the 3 trig functions. It's called SOHCAHTOA, and it's pronounced SOHCAHTOA. Everybody repeat after me. SOHCAHTOA. SOHCAHTOA. And this memory device helps us focus on sine, cosine, and tangent. We're now on the tangent lesson, so we're going to look at this TOA part. TOA stands for tangent, is the op leg over adj leg, right? And I'm going to literally write it for you here. Tangent, I'm going to abbreviate it tan. Alpha, it's tan of an angle, that's the format for the definition. Equals, that's the format. And it's going to be O, op, leg, over A is adj leg. So with this SOHCAHTOA, you can remember sine is op leg over hype, cosine is adj leg over hype, and TOA, tangent, is op leg over adj leg. And with this SOHCAHTOA, you can remember all three trig functions without having to just rotely memorize them. Just memorize the SOHCAHTOA, right? And do be a little careful with that. I've had students mix up the letters and or say it differently, and all of a sudden the letters change, and that can cause some problems for students. So this is op leg over adj leg. That's this one here. Op leg divided by adj leg. That's the format. You'll see us use it over and over. In fact, here we're going to use it right now. In the following figure, what is the proper setup using the tangent trig function? So let's rewrite our definition. Tangent alpha equals op leg over hype. Over A, which is adj leg. Good thing I was thinking of TOA, so I know that this is an O and an A. Then here's my reference angle. Notice they didn't use an alpha here. They just used a question mark, but we are focusing on this angle as our reference angle. This one's blank, we're ignoring it. This one's 90, we already know it. So there's only three angles, one we know already, the other two are the only two in question when it comes to trig. There's only two in question, one is being focused on, that becomes what they call the reference angle. All right. Tangent of this angle, because we don't know it, so we're going to leave it a variable. It's like calling something x when you don't know it, equals. Now we look for the op leg. There's only two legs attached to the, like a human, attached to the largest angle. Op is across, so that's 15. So that goes here in the fraction. There's a fraction bar. And then the adj leg is next to the reference angle, and it's the leg, 12. Why can't it be this side? Because that's the hypotenuse, you guys. That's not a leg. And the definition is op leg over adj leg of the tangent function. And this is our third function. We've learned sine from so. We've learned sine, cosine, and now we're learning tangent. We're going to do 3, and we're just going to use these on different problems. Okay. For the following figure, what is the proper setup using the tangent trig function? So let's write the definition. Tangent alpha equals op leg over adj leg. How did I know that? Because I'm remembering TOA from SOHCAHTOA, right? Tangent equals op leg over adj leg. So let's fill it in. Here's my reference angle here. That means the op leg is across from this. If my reference angle were there, the op leg would be over there. Okay, but it's not straight across. Op leg is across from op in geometry, so it's 15. I need an equals. I need a 15, a fraction bar, and then adj leg is 7. If it's adjacent or next to, why isn't it this side? Because that's the hypotenuse, it's not a leg. That's the names of the sides. This one does something interesting. They're teaching us, or at least illustrating to us, and I'm going to try to illustrate it to you here. If we don't know this angle, we can take this trig function and reverse it. So everything in math has a reverse or a backwards. We go forward with addition, we go backwards with subtraction. We go forward with multiplication, we go backward with division. We go forward with power, we go backward with root. We go forward with a tan function, we go backward with an inverse tan function, which is written tan to the -1 power. This fraction goes right into the parentheses here, 15 over 7. And I'm going to pull out my calculator here in a second and try to work a few of these when we get to the end, so you can see how it works inside the calculator. Let's go to the next problem. The next problem is for the following figure, what is the proper setup using the tangent trig function? So let's see here. Let's go ahead and write our definition. Tan alpha equals, notice I'm writing the same thing every time. Why? It's a definition. And it goes from the TOA. That's how I'm going to remember it, from SOHCAHTOA. In this case, I know what alpha is. I actually have an angle. So I'm going to say tan of that angle, 27 degrees. Now, I need the op leg. Op leg's over here, but I don't know it. Let's call it x. So put an x, a fraction bar, and the adj leg is 5. That goes here. And what we're going to figure out is if I multiply both sides by 5 using equation solving methods, what I do to one side I must do to the other to keep the equation balanced. 5 over 5 is 1. So I literally can find out what x equals by multiplying this out on my calculator, and I'll show you that in 1 second. Okay. I think I'm still recording, but my screen is jumping around a little bit. Let's see if that matters or not. Let's move up and do number 15. This up. So it looks like it's just my feed on the screen, you guys, and it looks like it might have just crashed.